All right, so let's keep talking about trigonometric functions and how we take the derivative. Remember that in the previous video we just talked about sine and cosine, and now we're going to move on to talking about tangent and cotangent and about secant and cosecant. So those are the other four if you needed a refresher on the 6 trigonometric functions. So I want to take you over to this screen. Let me take that away. We've already discussed that there's this nice little pattern between sine and cosine. The derivative of sine is cosine, and the derivative of cosine is negative sine. And I should, if I wanted to be really mathematically accurate, I should be writing things like the derivative with respect to x of sine of x is cosine of x. That's the right way to write this. However, I don't have enough room to show you all of these and compare them side by side and write everything out. So I'm just going to use these arrows. It might be a good idea for you in your notes to use that language, though, to write like d dx, the derivative with respect to x of, the next one we're going to do is secant of x. So write it out like that, equals. So if it's not too tough to translate that, you might want to write it into your notes that way so that that's how you remember it. If for some reason that's not making sense to you, you can feel free to check in with me in class. There's nothing wrong with the information I'm giving you here. It's just not quite as mathematically sound. I'm making up my own notation for the sake of space. So anyway, so sine of x is derivative of sine of x is cosine of x. Derivative of cosine of x is negative sine of x. Let's look at another pair of trig functions, and that is secant of x, which remember is actually 1 over cosine, and cosecant of x, which is 1 over sine. And I will give you the what the derivative is. So the derivative of secant of x is secant x tangent x. So they're being multiplied here. You don't have to write that in, but it's secant of x times tangent of x. Secant x, tangent x. The derivative of cosecant of x is negative cosecant x cotangent x. Barely squeezed it in there. So the derivative of secant is secant x tangent x. The derivative of cosecant is negative cosecant x cotangent x. So if you see, there is a little bit of a pattern here. The derivative of the two s's, sine and secant, both are positive. Positive cosine x, positive secant x tangent x. The derivative of both c function, cosine and cosecant, are both negative. So you might want to use that little trick to your advantage when it comes to memorizing. Also, you can see that there is some consistency between the form secant x times tangent x and cosecant times cotangent. There's some obvious, there's an obvious pattern there that we can identify. Use those patterns to your advantage. This is definitely something you want to memorize. You don't want to be looking back into your notes every time a secant function comes up. But there are only 6 of them, and because there's this nice pattern, you'll find that you really, if you can memorize 3, you can memorize 6, if that makes sense. So let's do the last 2. Okay, so we have sine and cosine, we have secant and cosecant. Let's talk about tangent and cotangent. So the derivative of tangent of x, let me find a new, so I have, what color haven't I used yet? Oh, we haven't done purple. We'll do purple. That's fine. Okay, so the derivative of tangent of x is secant squared of x. And the derivative of cotangent is, you can guess, it is negative, and it is negative cosecant squared of x. So again, we see this pattern of, well, the s and t functions, sine, secant, and tangent, are all positive. All of the c functions, cosine, cosecant, cotangent, all have negative derivatives. That's a nice pattern. And then we also see a pattern across in this in this kind of pair that we have, tangent and cotangent, we have secant squared and negative cosecant squared. So again, an obvious pattern that we can see here. So these are the 6 that you want to memorize. Sine, cosine, secant, cosecant, tangent, cotangent. So really just write those into your notebooks. Again, if you can write them with that little derivative with respect to x of the function equals this other function, then you'll have, you'll be a little bit more mathematically correct than I was able to fit on this one screen. Okay, I'm just pausing to make sure you have it all written down. Okay, if you need to pause the video further, please feel free to do so. But we're going to move to this other screen because I want us to go over one example problem. And here's what, if I was reading the problem, this is what the directions would say. It would say we have a function y equals secant of x. Find, whoops, that was kind of dramatic. Secant of x. Find y prime and y double prime. So we're thinking about the latter, right? They're giving us y. They want us to find y prime and y double prime. And so we're going to use what we know about the trigonometric functions to do that. So starting with y prime, this is just a matter of using a memorized, obviously not quite yet, but a memorized formula. The derivative of secant of x is secant x tangent x. And so that's it. That's the answer. You don't really have to do any math, any algebra here. It's just writing out the formula. But that's not the whole question. The question is also to find y double prime. So when we go to find y double prime, you might notice that we're actually dealing with a product where we're going to need to use the product rule because we have 2 trig functions. The first one, u, is secant x, and the second one, v, is tangent of x. So let's set up our little organizer here. Do it over on the side. U equals secant x, v equals tangent x. So let's find u prime and v prime. Again, we already know that the derivative of secant of x is secant x tangent of x, so we'll just repeat that. And we also know that v prime, the derivative of tangent, is secant squared. And again, I'm just taking that from the formulas. Secant squared of x. All right, let's see if we can find the solution here. So again, we're finding y double prime, which is getting a little squished there, but that's all right. We'll fit it in. Y double prime is v u prime plus u v prime. So we plug it in, tangent of x times u prime, which is secant x tangent x, plus, and I'm going to have to go on to the next line. This is not, I'm not making a quotient here, just running out of space. So we have v u prime plus u is secant x, and v prime is secant squared of x. And I probably don't even have to tell you that this can be simplified, right? We can take this secant x tangent x that's being multiplied by tan of x, and we can actually make this secant x tangent squared of x. And I will write that on, I'm going to write that over, well, actually, you know what? I'm going to write it with a different color because I don't really want to move to a different page. So we will take y double prime is just going to be secant x tangent squared of x, and then we'll take this part here and we can rewrite that as secant cubed of x. So we would say plus secant cubed, and that's it. We can't really simplify it any further than that. So our answer would be y double prime equals secant x tangent squared x plus secant cubed of x. The end. So we solved, they gave us y, we found y prime with our formulas, and we found y double prime using the product rule. So that's it. That covers all 6 trig functions. The algebra, the math work that we're going to be doing is really no more complicated than what we've been doing up to this point. The new things are we may need to bring back a few pieces of information that relate to like trig identities. So the whole idea, like in the last video, of secant squared plus cosine squared is 1. That kind of information might take us a little while to bring it all back to our more accessible short-term memory. And the other thing that is a little bit different is that we have to memorize these formulas. So contrary to something like the power rule, you have one rule that applies to all of these different functions. When it comes to trigonometry, there's a different formula for each trig function. And we'll get some time to look at those and see how they're all related. And maybe you'll find that you actually, if you do forget one of the formulas, there may be some ways that we could figure them out. Let's say you get stuck on a test. There may be ways that we could figure them out, but I will save that for class time. And I will leave you with that for lesson 5. You are all done.